everyone, welcome back to my channel. Hope you all are doing good. Now we are going to talk about how to detect outliers in your dataset using ZScore method. And if you have not subscribed, please start subscribing so that you will not miss any updates. And let us start without delay. Guys, here we are with understanding of our very important concept of outlier detection. And there are several methods by which we can detect our outliers, and these are a few very mostly used and most frequent methods of detecting it. One is Z-score method. So this method, whether assumes whether the data is normally distributed or not. So how it will do? It will calculate mean and standard deviation of your data, like whatever the data set you have. It is going to calculate mean and standard deviation of each data points, and that Z-score, whatever the values it is going to get, it is going to, like, we have the Z-score method, right? We have we are, like, whatever the data point we are getting, we are deducting with mean, and we are dividing with standard deviation, and that is what your Z-score is. And there is, like, we are defining a common threshold value or the minimum value where like it's going to compare with your Z-score whatever we are getting. Okay, and here we are keeping that value as 3. If it is greater than, if your threshold value, okay, is greater than 3, or that means if it is more than 3 standard deviations away from mean. Let me show you that what I'm trying to say in my whiteboard. So how your normal distribution curve is going to be, guys? It's going to be like this, right? This is your normal distribution curve. This is your mean line. So this is your mean. Okay. So when I have explained you what I told you, that the first, like, there are two methods, right? One, we have the 65% and 99.2%, right? So all those things. So that is nothing but a standard deviation, guys. So the first standard deviation will come here. Okay. So the first, this is the first standard deviation. Okay. How we are representing? We are representing like this: 1 mean minus 1 mean. This is your standard deviation symbol, right? Then we have second standard deviation level, where we are defining like this: 2 mean, then minus 2 mean. Then this is your third standard deviation, 3 second. So anything above, like from this side or this side, if the data points are coming anything beyond this point or beyond this point, that is what we were detecting in our like we have talked about so many things, right, in our statistics. And this is the whole thing, guys. The same thing, like if you want to detect your outliers with very large data sets, we don't know, right, where exactly that outlier is going to come. This is how we can get. We are taking the threshold value till 3 standard deviations, till this. Anything above or beyond this, we are considering them as an outlier or anomaly, right? So anomaly detection is an important task in our in this whole journey, right? So that is what we are going to discuss. So the first method we understood about Z-score. The next step is going to be interquartile range method. IQR method, I told you guys that we have interquartile range. That means that is a range which we are defining here, and this is less sensitive to extreme values than the Z-score method. That means if you have very extreme values, let me give you an example, that if you have data sets, right, where all the ranges of values are coming between 0 to 10. However, you have few values which are like 70 to 100. So consider that you have some 100 values of 0 to 10, with all the values are between 0 to 10. However, there are some 5 or 10 points which are coming as more than 70 or 80, 90, 100. That is your extreme boundaries. That it's very high distance, right, between all the data points. However, or the density is coming in one concentrated area. However, we have few anomalies at that point of time, and we need to detect and treat them. So interquartile range is not going to detect those kind of values much better as compared to Z-score. That is what it is saying. However, the IQR can be calculated by subtracting Q1 from Q3. Okay, so IQR formula is Q3 minus Q1. Then determine the outlier boundaries. So if we want to determine the outlier boundaries, how we can do it? The first boundary or the lower boundary is Q1 minus 1.5 into IQR, and the upper boundary is Q3 plus 1.5 into IQR. Right? So these are the two boundaries. Between that or beyond that, we are going to consider them as a outlier or anomaly. Then when to use which methods? So we understood these two techniques. If you are following any normal distribution, then Z-score is the best method, and that is a mostly used method. And if you have a smaller or medium data sets, you can take your box plot. Box plot is very good in detecting outliers, box plots, because if any points are falling above your IQR or the whisker points or whisker tail, that is going to be considered as an anomaly or outlier. And like I said, right, visual inspection, we have visual methods like box plot, scatter plot. These are very important, very effective way of understanding your outliers. Then in case of skewed data, skew, I told you, right, positively skewed, negatively skewed. In those kind of skewed data, IQR method is the best or the good choice. So in this example, however, we are going to understand on Z-score method. So here I have taken one simple line where I am just showing you, just to refresh your memory. We have already discussed this. SNS.get dataset names. It is going to give me all SNS datasets present, and I have taken here one dataset as health expense. And for that, I have imported all my libraries: Seaborn, Matplotlib, Pandas, and NumPy, and I am loading my dataset here. I'm getting my head of it. So this is what the dataset is containing. Features are year, country, spending. It's going to go. Year, country, spending USD, like expectations. Okay. Then if I'll the next step is what, guys? We have to get data.info. So here we do not have any null values. You can see all are non-null. Okay. Everything is having your data type and non-null count we are getting here. Then we have, so here I have written that we do not have any null value, so we do not need to treat our null values, right? We do not have to treat our null values. We do not have to fill it. Now, the next one I am taking is the line plot. So line plot, here I have taken few plots just for for my understanding where exactly the data is going to come more. So here I have taken one data, like I have taken one line plot where I want to show the spending USD, like in country, how many, like what is the USD people are spending or the amount they are spending, and based on the hue. So here you can see I have years present in 1970, 1980, 1990 to 2020, and we are getting the data something like this. So USA, from this data I am able to understand, okay, USA is spending almost $12,000 per year on an average. So in this plot is again one more line plot I have taken to understand the life expectancy. And here I have taken country and life expectancy. So I can see that USA is having less life expectancy on an average of 75 people are living. However, the other countries like Japan, then France have very better life expectancy. And in this one, I have taken box plot. And however, I'm not able to detect anomalies here. But I can say that USA is having, somewhat like we are going to get some anomalies in case of USA, because you can see all the other countries are coming in this range. However, USA is coming almost 10, like more than 8,000 to 12,000 ranges, right? So that is a bit over, I can say that overside, or like that should not be, or that should be in range. For that, we need to understand now how we can get our outliers set. Then the next one I have taken box plot, and box plot here I have taken for year and spending USD. So here I have taken country with spending USD. Here I have taken year and spending USD, and for that you can see that these are my outliers for these years from here, right? From here it is considering these are the outliers, and we can see it is giving me all the years data, right? Now we will understand, and what I understood from all this, like how I came up to know that where I can get my outliers. How can I know that? I understood, okay, from all these above plots that okay, my outliers are like I'm able to see only spending USD is having more deviations. My spending USD is having more deviations as compared to other attributes or other features. That is why I came up the conclusion that I can find some outliers in my spending USD. For that, I started using my ZScore method, and ZScore is a method of your stats. If I'll scroll to the top, we have scipy.stats, and this is your library. Scipy is your library, right? Stats is a module. This is your method. ZScore is a library inside that. And that ZScore I am applying here, and what it is expecting me to insert a column, and I have inserted my spending USD, and I am getting my ZScore for all. It's getting applied for all my data points. Now my, and guys, ZScore method I already told you, right? Let me just go to the whiteboard. If I just want to refresh your memory, if ZScore is something like this, no? X minus mu divided by standard deviation. This is a ZScore. So the same formula is getting applied for each and every data set, guys. Here for this data set, for this data, every data, it has applied that same formula and it is calculated. And how I got to know the mean and standard deviation? If I will get the describe of this, let me open this and see data dot describe dot. So if we see for year for spending USD and for life expectancy, I have my mean, right? This is my mean and this is my standard deviation. So it has taken this mean and standard deviation for each data point and it has calculated the values here mathematically or formula based. Then after that, I want to get my outliers. So what is the threshold point? I have told you guys, we have 3 and a minus 3, right? Anything greater than 3 or anything less than minus 3, which are considered as outliers. So the same method, I have taken one outlier as a variable, and I am applying my formula here. I want that G score values dot ABS means I'm getting all, like it's getting all the negative values it's going to make positive and it is going to calculate based on it. So here I am telling, okay, it should be greater than 3, like all my values should be greater than 3, right? So here I got 4 values and I do not have to check -3 because I have already taken the positive one. So I do not have to check the -3, only I have to check the +3 here. So I got 5 values here, guys. And the same thing I got to know from my plot, right? So same thing I'm getting it here. The life expectancy, J score, everything I'm getting it. And this one I am, plotting it to know where exactly that exact thing is coming. So this is how I'm getting. This is my scatter plot, okay? And again, one more scatter plot I have taken where I'm, keeping my outlets and I'm giving the color as red, okay? And grid I have taken. So this is how I'm getting my data, guys. These all are coming correctly. However, these 5 points are your outliers, okay? So this is how we can detect your outliers using your G-score. We will understand, guys, in our upcoming video on how to detect outliers with IQR method. So that is all. Thank you. Well, that would be all for now. We will cover further topics in our upcoming videos. Please start subscribing, like, share your comments, share your feedback, share your any doubts. Please reach out to me through comments or community. And see you till that time. Thank you. Bye.